All right, so using our worksheet from yesterday, we're going to talk about probability distribution and sample space. Thank you, Juan. So the first question on this worksheet is, it says use the table below to make a sample space and probability distribution for flipping 3 coins. Now, I know I said use the table. I was trying to throw you off because using a table to find the sample space for 3 coins is pretty difficult. Okay. Yesterday when we talked about rolling 2 dice, making a table worked out well, right? Because you can put 1 dice across the top, 1 dice across the side, and it was really easy to make a sample space, right? Now, if I have 3 coins, okay, what's the possible outcomes for 1 coin?
Heads or tails.
Heads or tails.
Heads or tails, right? What's the possible outcome for the second coin?
Heads or tails.
Heads or tails. Okay. Now, if this is my table, where am I going to put the third one?
Somewhere in the middle.
Okay. But I put it on the side, it could get confusing, right?
Yeah.
Okay. Now, there are ways you could make a sample space using a table. The one way to do it is to make a sample space using 2 coins, and then take the outcomes from the 2 coins and make it 4 by 2. All right, using these 4 outcomes as one side, and 2 as the other side, and make 2 tables. All right. Right now, you guys don't like making 2 tables, when we can get away with making 1 tree diagram. So, tree diagrams are kind of close to my heart. You guys get it? Because branches and trees. Come on now. I know. Gotta get a joke in every now and again. All right, so a tree diagram, the way this works, all right, is we need to start with our outcomes from our first draw, our first flip, or our first roll. Now, since we're using coins in this case, all right, let's figure out how many possible outcomes we have. So, Marcel, if I flip a coin, how many possible outcomes are there? 2, right? So if I flip another coin, how many outcomes are there? 2 more on that coin, right? So if I'm going to flip 2 coins, my total possible outcomes are 2 times 2, which is 4. And if I flip the third coin, we do 4 times 2, which is 8. So I'm going to end up with 8 total outcomes. So using our tree diagram, my first coin had 2 outcomes, heads and tails. So please use your worksheets, the top of your worksheet, and follow along with this tree diagram. So here's our first 2 options, heads and tails, right? Now, if I flip a heads with my first coin, and I go to flip again, what are my 2 possible outcomes?
Heads or tails.
Heads or tails. So we can get a heads on our second flip, or a tail, right?
Keeps going.
If I got a tail on my first flip, what are my 2 possible outcomes next?
Tails or heads?
Heads or tails. Nice. Okay. And then we have our second flips. Now for our third flip. If I got heads, my third flip possibilities are
Heads or tails?
heads or tails. Kind of repetitive. If I got tails, my third flip is what?
Tails.
Heads or tails. If I got tails, heads, my third flip is? Heads or tails. Awesome participation. If I get tails, my third flip could be?
Heads or tails?
Heads or tails. Good. Okay. So if I wanted to do 4 flips, then I'd start here and go heads or tails, right? I could do 5 flips, 6 flips, and so on. Okay. Now this works instead of the table because with the table, there's only 2 sides you can use. So it only works for 2 things, like 2 dice rolls, or a coin flip and a dice roll, 2 drawings from a card deck, and so on. But with the tree diagram, you can use as many flips, rolls, or draws, whatever you need to get to your final sample space. So our sample space now we can find by going down each branch of the tree diagram. Okay, so our first possibility is we get heads, heads, heads. Right? Our Travis, appropriateness. Okay. Our second possibility is heads, heads, tails. Okay. Our third possibility, heads, tails, heads. Fourth, heads, tails, tails. Then,
Head. Tail.
nope.
I got lost.
Okay, hold on a second, guys. Slow down. Jerry, we're just going down each of the branches. Okay? So tail, heads, tails. Okay. Then tail, tail,
Head.
head. So now what we've created is a sample space for flipping 3 coins. Okay. Does that make sense?
Yep.
Okay. So how many possible outcomes are there?
8.
8, right? That's what our prediction was, wasn't it? That's what our prediction was, right?
Yeah.
Okay. Now, is any one of these more likely than the other?
Yeah.
No. So we say that these 8 possibilities are all equally likely. Well, there's only one L in equally, sorry. All equally likely, okay? Because they all have the same probability. All right, so if any things have the same probability, they're equally likely. Okay, which means they just have the same probability. Now, using probability notation, what's the probability of getting 3 heads? Christian, how do you know it's 1 out of 8? Okay, there's only 1 3 heads, and how many total? 8. So our probability then is
1 out of 8.
1 out of 8. Okay. What's the probability of 3 tails? 1 out of 8. Okay, we can finish this up, can't we? Okay, I'd like you guys to try these. Okay, when it says first coin H, that means just your which letter? The first letter, the middle letter, or the last letter? First one. Okay. When it says second coin tails, which letter? First, middle, or last?
Middle.
Do
Middle.
it have to be like that in order? H, T, H?
Yes.
Like, okay.
Yep, that's a set outcome. Now, if I ask, what's the probability of getting 2 heads? Okay, then the order doesn't matter, Shaquila.
Okay.
Okay, so like if I say, it's like here I say 2 H's, order doesn't matter just as long as there's only 2 H's. All right, so try to find those probabilities. Okay. Reduce if you can. Reduce if you can.
What do you mean?
So first one is an H. Sorry, first letter. First letter is an H. So how many of them have the first letter?
Oh, it's already up. It says 2 H's. Does that mean 3 of them could be H?
Nope. 2 H's means there's only 2.
We gotta make our own again?
Yep, and the last 2 make your own.
I don't want.
Give you a chance to be creative, and you choose not to.
Are you still recording?
Oh. All T or all P.
All T is already used.
Alright, fine.
Need help? Let me know.
I'm doing all H then. That's already used though.
Right there.
T in the middle is already 1. T in the middle already is 1.
Wolf?
How many H's is it? Use it?
Mr. 2 H. They got out just 2.
I'd say 2 or 3. Right?
That's good. The odds be like
What?
The odds be like out of
Because there's only 8 total. There's only 8 total outcomes.
How do you write these ones?
OT. That means 3. 3 OT. Which one's OT?
Okay, you figure out how
1
many.
over 8.
Ray, right there some way, dude.
Huh?
Oh, another one. It's right here.
2H.
How many are there?
Which one's 2H?
No, like how many times you see each H?
1, 2,
Well, how's that actually go?
3
Once, right?
over
No. HTH, in that order only happens once.
You make another
That means the probability is 1 in 8.
creating one.
First and third rotate.
THT, TTT. I don't know.
That's first and second.
But I use first and third.
Oh, okay. I know what you mean.
Yeah.
Okay. Yep, that's good. All right, so let's try these.
Right, sir.
What's the probability of HCH?
1 out of 8.
1 out of 8. What's the probability of TTH?
1 out of. Wait, what?
TTH.
1 H. 1
There
H.
is.
Oh, 1 out of 8.
1 out of 8.
1 out of 8.
Okay. Now, first coin H.
4 out of 8.
4 out of 8.
Okay.
1 half.
First coin is the first letter, so there's 4 out of 8. That reduces to
1 half.
1 half. Now, another way we can look at this. Our first coin was the first, was where we started, right?
Yeah.
So I can just look at my first flip right here and think how many are heads? How many of these are heads? 1 out of 2. Greg, General Alexis, got a question? Got a question? Okay. So, since I have 1 out of 2 here, that's the same as counting our first coins here. Okay? Alright. Second coin T. Yes. Second coin T, how many are there? We got 1, 2, 3, 4. So 4 out of 8 or 1 half. Okay. First and second.
8 out of 8.
First and second coin being a T. Now, first and second means both the first one and the second one have to be a T, right? So no first T's. First T, no second. First T, no second. First and second. How many are there? 2. And 2 out of 8 reduces to 1, 4. Okay. Now an OR statement means one or the other. Now this is where a lot of people are making mistakes today. Okay. First and third. What they'll do is they'll count. They'll say first. So 1, 2, 3, 4. Okay, no more firsts. And they'll come back and say, okay, I'm gonna count my thirds down. 1, 2, 3, 4. 4 plus 4 is 8. Okay. Are they right? No, because they double counted which ones?
All the T's, all the ones that start with T.
Okay. They double counted these two, didn't they? H, 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 and HTH. They double counted those. Okay. So when we have OR statements, make sure you're not counting one that satisfies both conditions. Right? So first or third, 1, 2, 3, 4. Already counted those two. 5, 6. So it's 6 out of 8. Okay. Okay, all T's. How many?
1 out of 8.
1 out of 8. Now, 2H. The most common question after this was, does 3 H's count? The answer is no, because I'm asking just for 2 H's.
3 out of 8.
Okay. So how many have 2 H's? We have 1, 2, 3. So what was it, Travis?
3 out of 8.
3 out of
You
8.
should
Good.
reduce your one
Okay.
to up.
Oh, yep, I should reduce 6/8 to what? 3/4. All right. Are there any questions? Any questions? Okay, now, anyone want to share some of their that they came up on their own? What was it, Christian?
It has 4 H's.
Okay, so probably of 4 H's when we're flipping 3 coins. What is that? 0, because there's no way I can get 4 heads. Right? Michael?
The H in the middle.
Okay, having an H is the second coin. Right? So an H in the middle. So what'd you get?
4.
4 out of 8. Good. Okay, anyone else want to share theirs? Christian?
2 T's or 2 H's.
2 T's or 2 H's. Okay? So how many 2 T's or 2 H's? 8?
8 out of 8.
Well, this is 3 H's. And that's 3 T's.
6.
Right? So it should be 6 out of 8. Okay?
But
All right, anyone else? All right. On the bottom of that worksheet and the bottom of the front, it talks about this thing called probability distributions. Okay? So we're probably wondering what probability distributions are. So what we're going to talk about now is how we can take a sample space and make a probability distribution. So we're actually going to start with the coin side, or it's not the coin side. Sorry, the dice side, where we rolled 2 6-sided dice. Right? So we need to use our sample space from the 2 6-sided dice. Now, before we go on and actually figure out what probability distributions are, we need to know what a probability distribution is. Okay? A probability distribution distribution is a list of all outcomes. Please stop flipping the coin.
Stop, Greg.
With their probabilities. Travis, got a question?
No.
Okay, so why are you talking to Marcel? Okay. So a probability distribution is the list, guys. Take notes. Marcel, stand up.
Stand up.
Okay. Stand up. Okay, you taking notes still. Right. So probability distribution is a list of all outcomes with their probabilities. Okay? That's what our probability distribution is. Now, if you look at the bottom of either of these two pages, you can see that I have multiple probability distributions, right? On the first page, we were talking about the rolling 6 dice. There are 3 probability distributions. Okay? What I'm trying to show you here is that you can have multiple probability distributions for each sample space. Back straight. Okay?
Oh my God.
Marcel, go in the hallway. Okay, guys, you can have multiple probability distributions for each sample space. What? Guys. Okay. There isn't just one probability distribution. We can do multiple. And on your worksheet I've given you, there's 3 for each. We're going to do 2 as an example, and I'm going to have you try the other 4 on your own. Okay? But I will help with those other 4. All right. So write down this information about probability distributions. Okay? Make note of that somewhere. Either do it in your notes or on your worksheet. That way you have it. Then I need that space in a second, so I need to erase that. What do you guys write? Travis, go pick that up. Don't make any face at the camera. I don't want to make the camera, okay? Okay, I'll go recycle that. Thank you. Alright, so probability distribution is a list of all outcomes with their probabilities, and we can make multiple probability distributions for each sample space. Alright, now like I said, I'm going to need to erase that.
No.
Alright? Damn. You guys like 10 minutes? Can we don't do sentences?
Yes, it's
Sorry,
not.
That's alright. That's okay. I'm just giving you a hard time. Because you're too busy throwing paper, Travis.
Yeah, he's throwing your family.
I'm not fully grown.
You're throwing your dead family. Really not. They cut y'all very much.
Alright.
Not the black one. Not the black.
Shaquila, this is on your worksheet I just gave you.
Oh.
Okay. Alright, guys, if you don't have it all the way down yet, copy it from a friend real quick. I'll help you out in a second.
Never mind, I'm good. I'll just do.
Alright, good.
Alright, good.
Shaquila, I'll give you the 2 sentences in a second. So, probability distribution for sum of 2 dice. Now, this is on your worksheets. It's on the bottom, on the front side. Okay, the side that has your name on it. Alright, bottom left corner. Okay, so it's on this side, bottom left corner. Alright. Now, the outcomes is the list of all the outcomes for the given situation. So this one, we're talking about the sums, right? We're not talking about 1, 2, 1, 3, 1, 4, 1, 5. We're talking about the sums. That means we're adding the 2 dice together, right, Jared? Okay. So what's my smallest outcome? 2. What's my largest outcome? 12. So our outcomes are 2, 3, 4, 5, all the way up to 12.
Oh, they're already in there, and I just started writing them down.
Okay, so that's the list of all my outcomes. Okay, so I'm halfway done my probability distribution. The other half is to find what? Probabilities. Okay, so if I'm going to find the probability of a 2, that means I'm going to look at my sample space for 6 dice, or sorry, not 6 dice, for 2 6-sided dice, and see how many times I roll a 2. Now the only time to get a 2 with 2 6-sided dice is 1, 1, right? So what's our probability? 1 out of 36. Okay. Looking on your sample space for 2 6-sided dice, how many times can you get a 3? 2. So our probability is what? 2 out of 36, or you can write it as 1 over 18. All right. What about 4? How many times? 3. 3 out of 36. 5. 6. 5. Okay, can you guys fill the rest of that in? Okay, if you're having trouble figuring out the probability, look in your sample space, count how many times you get that outcome. Okay? So if I'm looking for the outcomes for 7, I'm looking for 1 and 6, 2 and 5, 3 and 4. Okay, those are the outcomes I'm looking for. Right?
Oh, it does go back down,
Does it really? Did you just keep going?
doesn't it?
It goes 6 to 5.
Yeah.
It goes what? It goes back down after 6.
Oh my gosh. That's all I got.
Travis, you're supposed to look at the table to count them, not just think you're bad.
Yeah, right here. 10, so I can try to
Okay, some of you might run a pattern going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Remember, we're getting these 5s, 4s, 3s, 2s, and 1s out of our sample space for 2 6-sided dice. Okay, so you guys see how many times they add to the number. So, how many times do we get 7? 6. How about 8? 5. How about 9?
4,
10?
3, 2,
1.
1, 0.
Okay. Well, we're not about 13.
You're just not
All right. So here's all my probabilities, right? Now, cool little thing you can see. If I take these probabilities and I add them all up, what do you guys think I'm going to get?
36.
36. You ready to do it?
72.
Or you just guessing?
That was a guess.
Okay. You're right. Now, remember when we add fractions, guys, we only add the tops. Okay? So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. If I add those all up, we get what, Greg? 36. And does anybody know what 36 out of 36 reduces to? 1. So, guys, what that tells us is the probability of rolling with 2 6-sided dice, a sum between 2 and 12, is 1. So that tells me that every time I roll a 6-sided dice, then I'm going to get a number between 2 and 12. All right, does that make sense?
Every time you roll 2 6-sided.
2 6-sided dice, thank you. 2 6-sided dice. All right? That's a good way to check yourself. Guys, anytime you do a probability distribution, your sum should always be 1 when you add up all the probabilities. Let me say that one more time. Anytime you do a probability distribution, if you add up all the probabilities, you should get 1. Okay, so that's a good way to check ourselves. All right, let's flip the page over. Flip the page over. We're going to do a probability distribution for the outcomes of flipping 3 coins. Erica, where can I find all the outcomes?
On the tree.
Okay, on our tree we made earlier, right? So our outcomes, and you guys can write this in your table.
He didn't plan on it.
I just copied and pasted at the same time.
Me too. About plagiarism.
I made the table myself, Michael. So there's our outcomes.
No offense to you.
There's our outcomes for flipping 3 coins, right? Right?
Yeah.
What's the probability of 3 heads?
1.
1.
8.
What's 2 heads or 3 heads and a tail?
1.
1 of 8. Heads, tail, heads.
They're all 1 out of 8.
Okay, good. All these are 1 out of 8, if you remember from earlier, right? These were all equally as likely, right? So they're all 1 out of 8, right, Jen Alexis? Thank you. Okay. Now those are all of our probabilities. Now what was the check I just told you guys? Why are you not taking notes? Okay. How can I check to make sure we did it right? Okay. If we add them all up, what should they add to? 8 over 8. So I add all these up, and we get 8 over 8, which reduces to 1. Okay. Are there any questions on how we made those two probability distributions?
No, sir.
No? No questions?
No.
I didn't do the same thing.